Good afternoon, everyone. The authors and invited guests, I welcome you all to the technical session 9G. Myself, Siddesh Mughal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIAS Holistic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15 December 2025 in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16 and 17 December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session, Dr. Sanjeev Kumar Angdi. He is an associate professor and dean faculty development at Nutan Maharashtra Institute of Engineering and Technology, Pune, India. With over 12 years of experience, he is specialized in computer vision, image processing, machine learning, and deep learning. Dr. Angdi is committed to fostering faculty growth, advising research in intelligent systems, and guiding students towards innovation in emerging technological domains. Next we have, First we have Veena V. Karangar. She is present in a comprehensive review of text summarization using various deep learning and machine learning techniques. Ma'am, are you there?
Hello.
Yeah, ma'am, you're
Yes.
audible.
Yeah. Yes, Siddesh, I'm there. Yes. Is it visible now in the slideshow mode?
Yeah, ma'am, you can continue.
Can I start? Good afternoon, everyone. My name is Veena Kangralkar, and I am giving a comprehensive review of text summarization techniques using various deep learning and machine learning techniques. My paper ID is 1080. Uh, why text summarization? A lot of data gathering day by day, not easy for us to handle, not easy for us to read. Even when I'm trying to read any news, I do not go for complete reading of the news. I just take some important points from anybody and try to see myself what is the news there. Okay, so we are basically not interested, or you can say we don't have much time to go through these huge documents, and we have them a lot more. So I have picked up one of the NLP's primary applications, that is a text summarization, to condense my documents through a language that I would like to work on. Now, what is exactly text summarization? It's very simple. You have a document that goes through the NLP processing, that is natural language processing, and you get an extracted summary. Now, it is very important that the summary that you have got is of what level, whether it is with the context, out of context, or it doesn't have any relationship with what information you wanted from it. All right. So there are three basic types of text summarizations. The two prominent ones are extractive summarization and abstractive summarization. One more to our addition is hybrid. So let us see what is an extractive summarization. So extractive summarization is basically like we all have gone through in schools. We used to have this huge essay, and used to be some questions that we had to answer. So we used to read that essay, and then we have to write the answers to those questions from the same text, from the same essay, nothing from your own. If Raju has which color ball, Raju has red color ball. So this was the answer that we used to give. And that is extractive summarization, which picks on the important sentences from the data itself. Now let us come to abstractive. Abstractive is very common now. Abstractive is human-like summary that it gives us. That means you ask me about a movie, and I'll just explain you in my own words what is the movie all about or how it was. So I'm not exactly telling you what was there. I may add something extra from my point of view, but I try to maintain the context. That is abstractive. Hybrid is the new thing that is coming up, where it is trying to load the good from the extractive and good from the abstractive. So it's new, it is still growing. All right. So what exactly happens in a summarization pipeline? First is the pre-processing. Whenever we have data, we know that the data is not right. It is in its raw form. And for especially NLP applications, we need the data to be the type of data that we want. So it should be, unwanted, all the unwanted noise, everything should be removed. Then comes the feature extraction. Feature extraction is very important. Basically decides what summaries you are going to get. So that is one important factor that we have to consider. Then comes your model deployment or model processing. You choose the model that you want to work with and let the model work according to with your data. And once you are done with it, you get the post processing part, that is the summaries. Now you have to decide whether these summaries are right or wrong or nearby. Like what is the score that you're going to give them, how much accurate they are. So what I have done here is I'm having my PhD work in this particular area itself. So I did a survey on the various summarizations. So first is the extractive summarization. Now, in extractive, we basically start with the traditional machine learning languages. We have the term frequency, inverse document frequency, which notifies the important words. We have our support vector machines, decision trees, logical regression, which is more into classification and all. Then we come to deep learning based methodologies where we have our convolution neural networks, which is trying to gather the semantics and try to understand which sentences should we take and which sentences should we leave. Then we have our long short term memory, which takes the input, understands, and then forgets about it. Okay. The important point here is the attention based ranking, which was later introduced in our transformers, which was a groundbreaking invention. Then advanced extractive models that have stood out is generative adversarial networks that helps in generating your summaries with extractive models. Then there was a deep summarization model which uses the deep learning techniques to give you good results. And then reinforcement based learning, that is, it learns from your mistakes. Okay. So what we gather from traditional extractive summarization models are they perform very well. We get good raw scores, but the coherence is what we struggle. And coherence is very important for summarization because you require similarity. You need to understand how correlation is. Next is abstractive. Now, in abstractive, we have very popular models like sequence to sequence, which is encoding on one side and decoding on another side. Introduction to attention mechanism, which gives importance to each of the words and sentences. And then you have again pointer generator networks, then transformer based models. This was like from we all know from the 2017 paper Transformers, attention is all you need, where transformers the neural network which gives attentions to important words, and due to that the summarization has gone to another level. So we have T5, that is text to text, and then pre-trained model for abstract summarization, Pegasus. And upcoming research in the later 2025 have also promised about diffusion based summarization, which helps to give you summaries without any noise. It goes on canceling the noise and helps to generate better and better summarizations. And a lot of scope is for cross lingual transformation, that is multilingual, which is trending now. So you cannot say that I just want to work with one language. We can work with multiple languages. And these were the groundbreaking technologies that were recently developed, like domain specific transformations, HISTBERT, historical text consideration, and knowledge based biomedical, that is, biomedical data is considered. So, overall, abstractive summarization really give you good context worthy summaries, but it requires high computation and they are data hungry. If you do not have a proper database, you cannot expect good results. Finally, we come to hybrid. Hybrid is still immature, still we are learning. We are trying to mix and match and then try to see how it works out. So we are taking standard models and then trying to combine together, like factual consistency constraints are captured by the diffusion model. So we are still learning. We are very new at this. So we cannot say that hybrid is a new thing. It's just coming now. Yeah. Very important part here is the data sets that we are looking at. You know, High resource is the one which are the available data sets for us, which is most of the time in English language. When we come to medium resource data set, we have Hindi when we consider Indian languages or Bangla. A lot of work has been done there. And when we come to low resource are the languages which are not touched more, like Kannada, Marathi, Telugu. Okay, these are the languages which are not touched much. So we have to try to, explore those. A lot of research is pending there. It is underexplored. Now, these were some of the data sets that I have used for my work, like CNN Daily Mail, you know, the BBC News, all these things. But most of them were in English languages, and I'm trying to work with our Indian regional languages. So it's quite a challenge. Challenge because
Ma'am,
the
sorry to interrupt, but your
yeah.
9 minutes are over. So kindly wrap up.
Yeah, done. So this is metrics evaluation where you can see row scores, the that is correlation metrics. They give you better results compared to recall and precisions for other machine learning languages. So basically, we always go for a metrics consideration in row scores. Gaps. Okay. Linguistic and structural complexity, definitely. Limitations on extractive summarization. Yes, there is no fluency there. Data set constraints. We need to build up data sets. Data quality issues. You may have the data, but not in the right way that you want. And model architecture gaps, definitely. So conclusion would be that I have used Prisma technique, to figure out 25 pages, standard pages that really help me work through my research. And what I understood is transformer-based models have been a revolutionary and they are really better. So we need to experiment more with them, but also we cannot rely on them completely. We have to go for new models like diffusion models and so on. Finally, future scope में what we have to do is work on low resource languages. We have to do that since we are in India. We have multiple languages and rich vocabulary. We should try to work on them and try to get summaries that are not hallucinating, not factual, and they are concise, but they, retain the context. This is what I wanted to say. This is some work that we are still going on. This is a small project that we are working on where we are trying to take school students' books in different languages and then try to summarize them and produce summaries in different languages. So this is still a start. We are using Llama model, and it might not be very strong because high competition is necessary for this. Thank you. This is what I had to present. Any queries?
Hello, ma'am.
Yes.
Yeah. So yes, a really good presentation
Thank you,
with
sir.
respect to test summarization. So
Yes, sir.
right now, as you have combined you have analyzed the different, we can say, deep learning and machine learning models.
Yes, sir. Yes,
Yeah.
sir.
Based on your reviews,
Yes,
so
sir.
right now, currently, considering the latest research with respect to test summarization, which is the
Yes, sir.
best algorithms or methods which has been considered and why?
Okay, sir. Sir, basically the best is with we are going with transformers. Why? Because in generative way, when we are trying to generate summaries, no, sir, transformers have the speciality to provide important things, important scoring, without losing the meaning. So right now, transformers are the best, sir. They are the best.
Okay, okay.
Along with that, we can combine with sequence to sequence. Not a problem, sir. We can use sequence to sequence. It will also, along with that, we have to go for some new type of things. Like, for example, now DeepSeek use distill learning. So
Hmm,
I have used distill learning in my research where we are
hmm,
trying to have a teacher and master model.
hmm,
Master model is a bigger version and teacher is a smaller student is a smaller version. So that computationally we are trying to reduce, sir. The computational
hmm, hmm.
costs are too high. So we are working on that.
Okay. So
We are
is
trying
this
to
your
reduce.
research work?
Yes, sir. This was my survey for my
Hmm,
research
hmm.
work.
Okay,
I'm trying
okay,
to work in our regional languages because
okay.
summaries, we may get summaries, sir. But
Hmm,
when we come to specific domain, no, that time we may get some hallucinations or biases. So
okay,
we are
okay.
working on that, sir.
Okay, man. Thank you, thank you.
Thank you so much, sir. Thank you.
Thank you, ma'am. Thank you, sir. Moving further. Next, we have Shreyas Sawant. He's presenting AI augmented attachment for disabled.
Yes. Am I audible?
Yes, Shubham. Yes, sorry.
I'll share my screen.
Yeah.
Okay.
Veena ma'am, you can stop your screen
Yeah,
sharing.
yeah, yeah.
Yeah.
Okay. So we are students of NMIMS, and my name is Shreyas Sawant. My paper ID is 960. And the topic that we are presenting on is AI augmented attachment for the disabled. So the idea behind this project was that we wanted to create something which is for people who have vision related issues and hearing issues. So this is like a two product project that we had made as part of our capstone project. This was the literature review that we did, and from this we felt that there are a lot of solutions out there for some of these problems. Like for example, there are glasses which help people to like they give them output so that they can know what is in front of them, etc. But all these products are like separate as a separate product, and most importantly they are very costly. So what our goal behind this project was to make it as cost effective as possible and to augment as many features as we can. So for this, what we have done is that I'll just skip to the yeah, this is the methodology diagram. Here, this is the deaf module, basically for the people who have hearing loss. And there are like two main features that are in play here. First is the audio direction detection, and the other is the sign language keyboard. So for the audio direction is that we have a transparent display as the front end or like the output actuator, and this display basically just shows from which direction, right or left, did the sound, any major sound, like if for example if a person is walking on the road and a car is honking at them, but since they won't be able to hear, it will be showing them from which direction some high intensity sound was coming, so that we can draw their attention to that noise. The second feature was sign language keyboard. This is not for the person who will be using the uh, device. It is for someone who might be communicating with them. So, say for example, the person is not able to speak in English or Hindi, any normal language, and they rely on sign language for communicating. But the person in front of them aren't familiar with sign language. So, what they can do is that in front of a camera, they will perform like a keyboard. So, like how in a keyboard we have all the alphabets from A to Z. So they will be able to type the alphabets through the help of sign language, and a sentence will appear in front of them. And after some waiting time, it will be spoken out through a speaker to the person in front. So the person in front will be able to listen to the English language, and communication is possible. So the next product that we had was for people with vision impairments, and this one has speaker as the main actuator or the front end device, and again has two features. The first feature was object detection, wherein it will be able to detect all the objects that are in front of the person. So this will involve YOLO V8, which we have used for detecting any everyday object. These include significant objects like laptops, mobile phones, chairs, tables, some other person, animals that can be for indoor navigation. Our plan was to also inculcate outdoor navigation. However, since it relied on internet and getting access to GPS, we felt that that is something which we can do in the future and stick to just the indoor navigation. So what it does is that it will detect the objects, and there will be a text-to-speech engine like PYTTSX3, and it will be able to say whatever is in front of the person into their ear so that they will know and be able to navigate their indoor surroundings. The next feature that we had was what we call reader mode. So this feature is basically for someone if they want to read some newspaper article, some textbook, any novel or anything that they want to read. It works best on printed text for now. For handwriting, we have to tune the models better. So for this, we have used PyTesseract from Python library, which will do OCR, and it will again give the read text to a text-to-speech engine, and all this will be sent as the output in the speaker to the person. So this is like a technology overview wherein we had used YOLO V8, and the main board, the hardware that we used for this was Radsa 03W, which is a very compact SBC. It is like its dimensions are 65 millimeter by 44 millimeter, so it is smaller than the palm of a hand, and it has 4 GB of RAM. That's why we felt this to be apt for running all the models that we had. And this board is used for both the modules, so it's for the blind module as well as the deaf module. Moving on to the algorithms and AI models that we've used. So the first one which we relied heavily on was YOLO V8 for object detection, for even reader mode to detect where is the typed text, so it will be able to detect. And we have used the medium-sized version so that it will be able to run well on the hardware as well. And it had given an 85% of mean average precision. And next, the model that we had was PyTesseract, which relies on ResNet 18 for OCR. So it basically reads the text that is there in front of the person. And the model for sign language detection that we had was random forest classifier. It basically person will be doing sign language in front of the camera, and the classifier will classify whether it is which alphabet, and the accuracy that we achieved with random forest itself was very satisfactory. Therefore we stuck with it and didn't move ahead with any ANNs or RNNs, because that would mean more compute, and compute was something which we wanted to minimize as much as possible. For sound direction detection, we used simple algorithms, basically, which were the
Excuse me,
formulas
Swapnil.
wherein we first, yeah, yeah.
Uh, your 9 minutes are over, so kindly wrap up.
Okay. Yeah, yeah. So yeah, the tools and framework was Python, PyTesseract, PyTC, PTSX3, and basic libraries like NumPy, scikit-learn. And some of the results are here. So this was the hardware implementation, wherein one purple container has the battery and the other container has the main board and all the other sensors and actuators that we had. Um, and then these are like the results of the random forest on top, figure 2.5. It shows random forest and neural networks accuracy. So neural network took a lot of time for execution, therefore we ran with random forest. This is the sign language keyboard UI. So this is what it will look like for the typing experience, but it is just the UI purpose. The person won't be seeing this. And this is the reader mode's results. Then this was for the object detection. And we also had a face recognition module, but that was like still a work in progress, so we kept it in future scope. And so for conclusion, we would like to say that YOLO V8 and ResNet 18 were big players for us for this whole project for both the modules. And even for random forest classifier was very helpful for detecting the sign language. For future scope, like we said, integrating GPS, integrating the face recognition feature, that would be like the main purpose of increasing the project. And these were the references. Yeah, so that's it. Thank you so much. Please, if there are any questions.
Yes, Shreyas.
Yes, sir.
Couple of questions, yes.
Hmm.
So, with respect to existing work, because when we say disabled, so there
Hmm.
are so many work being carried out. So, considering AI,
Hmm.
so how you are going to say that your work is better than any other work? First,
Hmm.
second, why only random forest?
Okay, okay. So for the first question, How our project can be better is that we researched quite a lot on currently existing products, be it from Meta. We realized that Meta had created new glasses, and even Lenskart for the Indian market. We had researched that Lenskart had made glasses for like phone calling and stuff like that. But what we
Yes.
realized is that the prices of these products were very high for someone who might not be able to afford these products, because
So,
it's like these products aren't a luxury, they are supposed to be a necessity for some people.
okay.
So the main goal was to reduce the cost.
So right now, as
And
you are talking about a
yeah,
product, so
mhm.
have you analyzed what will be your product cost if it is being developed
Product
in the
cost.
later stage?
Yes, so we analyzed the product cost, and it was coming at an around 10 to 15,000. The main cost was for this SBC, the board. It was 6,000 rupees. However, there are a lot of the components of the board, like the HDMI port, a few I/O ports that we are not in use using. So if we are to make a product that is specifically catered for our uses, then the cost of the board can also be reduced, and we can probably even reach 8,000 for this. So
Okay.
yeah, that is for that. As for the random forest,
Hmm.
actually the main goal for us was to reduce the compute on the board, because it was like we have to run YOLO, we have to run ResNet, big models on the same hardware, and managing bigger models would mean to have compute, and which we didn't have with this board. It had a 2.4 gigahertz processor, and it had only four CPU cores. So what we wished was to reduce the compute as much as possible, it's not that we didn't experiment with other more advanced AI models. Like we also tried with RNNs, we tried with ANNs, but we were getting similar results with a random forest classifier as well, and it was like much faster than those. In the
Okay.
result chart as well, we saw that neural networks took like over a minute for execution, while random forest was just 3.8 seconds.
Okay. Okay. Thank you.
Thank you. So can I stop this screen share?
Yes, sir. Yes. Thank you so much.
Okay, thank you.
Yeah. Next we have Krisant Manikandan. He is presenting AI-powered dual model system for reputation risk detection in social media post. Do we have Krisant?
Yes, sir. Good afternoon, sir. Is my screen visible?
Let me check, Krisant.
Yeah, it is visible.
Yeah, it's visible. You can
Yeah,
start.
sure, sir. Good afternoon. I'm Krishan from Karuna Institute of Technology and Sciences, Coimbatore, doing my final year in Division of AI/ML. Today, I will just take you through my conference which I have done for this semester. So, yeah, let me begin with the context. This is like we are currently operating in this reputation battlefield where the core challenge is that which is leading to context propagates instantly online and severe social economic facts, all those things comes to play. The weakness in the current defense mechanism is that this traditional filtering like keyword backslash and then static rules, all those things easily come into play. So mainly my problem statement is that there are many social media posts and uh, things that go trigger and viral. So like it will be just going through all those images, context, comments, and it will tell whether this post will be triggered by AI or will it be like getting any copyrights or something. Yeah, coming to my third slide, this is like why current moderation tools fails. So why are existing tools failing us? Like we identify three main flaws in this. First and foremost, it's like most system analyze text or images in a single way, like isolation. So they miss the thread that arises when a harmless image is paired with a specific caption. And second thing is like they lack the ability to adapt to new slang or trending topics or the available the evolving language. And finally, the result may lead to consistent failure or to detect nuisance risk or leaving brands and users vulnerable. Uh, Basically, my core research perspective is like I just identified specific gaps that our paper addressed over here, which is the lack of multimodal synthesis. Current frameworks struggle to effectively fuse signals from text, images, hashtags onto a single reliable score. And moreover, in the second, the absence of trend awareness plays a major role. Existing systems doesn't look at real-time data such as these Google Trends, all those things which can be gathered through API or something to evaluate how risky a specific tag is at a specific moment. And finally, the operational challenge is that it is difficult to build a system that is more accurate and explainable and which can be adapted and fast given output for the real world deployment. Coming to my proposed solution, so here we are proposing an idea based on the trend awareness and dual model framework. So this introduces into three main concepts, which is synergistic analysis, adaptive trend integration, and automated content revision. On the first place, we joint analyze text, images, and tags to understand the full context of the single post which a person is uploading in the social media. And the next place, we dynamically adjust the risk score based on the what to say real time public interest. Like it will be analyzing the entire post. And the third place, unlike the other systems that block content or block the unwanted posts, our system will be like giving some changes to alter the post or something in the future. Coming to my architecture workflow, this is our basic system diagram. It follows a single workflow. Like in the first place, you will be having an entry validation. The post will be coming through this place, and it is split into three streams, which is the word examiner, the visual examiner, and the tag examiner. The word examiner is for analyzing the text. The tag examiner is for analyzing uh, hashtags, all those things, and the visual examiner, which will be analyzing into trending images, all those things from your post, and it will be giving you a threat
Sorry to
fusion.
interrupt you, sir, but your 9 minutes are so kindly wrap up.
Yeah, yeah, sure. So like it will be giving you a signal feed, like which will be consolidated to the data to calculate a final risk score and give you whether it is criticism or workplace or it can be kept or not. Coming to my models and algorithms, for textual analysis, we have used BERT-based classifier. For visual analysis, we use deep learning convolution neural network, specifically ResNet. For tag analysis, this is a unique contribution, so we just use PyTrends and we just gather some real-time data from Google Trends as well. Coming to the data set, we have gathered 12,000 around images to identify all those things, and which can be hateful memes data, toxygen, and internal moderation data sets. And coming to my results and key findings, as you see in the table, our proposed dual model system achieves 91% accuracy, which is gathered from the previous data which we have gathered. And our F1 score is also superior to something around 0.9, which is crucial. So we achieved this with a latency of 95 ms, making it useful and viable for real-time use. And then finally, I conclude by just telling this uses unique text, visuals, and trend analysis by combining all the features into a single model. Where this tool helps user to fix content rather than just punishing the post which the person has been uploaded in the past. It will be giving you some advices and also tells you how to alter the post, how to alter the content, so which might not get punished in the future. Uh, that's also so. This is the keywords that is associated with my research. And thank you for your time. I'm now happy to get questions from your side.
Yes, good presentation and a
Thank you,
good
sir.
topic to have as a project. So, You have implemented this, right?
Yes, sir.
So real time social media post, have you analyzed on real time, or it is only on the data set?
So actually, we just used two mediums. One is through Google's API, which is a real-time data set where we can gather all the real-time data from as well, and
Hmm.
also, we are using the data set as well. So this
Okay.
will be running in a parallel pipeline. So when connected to a social media API, it can analyze live posts with some milliseconds gap difference, and the risk score might be safe and content might suggest accordingly. So it is done through dataset based as well as API based.
Okay, it is through API based. So algorithms, when you are talking about, you have at parallel three different that is analysis on the text image. So
Yes, sir.
only BERT is sufficient, or other algorithms?
So actually, we are using three ways like image, text, and hashtags, right? So in this, we are using BERT specifically. So
Hmm.
which is not sufficient for all the three,
Hmm.
because a BERT can be analyzed only for this text analysis.
Hmm.
For image analysis, we will be like we are using this deep CNN models like this ResNet efficiently, which is exactly for this visual feature extraction of the image.
Hmm.
And coming to my hashtag thing, like we will be using uh, STL decomposition in the future, but right now we are using LSTM based search detection for this identifying whether the hashtag is controversial or good or bad.
Yeah, fine. Thank you.
Thank you, sir.
Thank you, sir. Next, we have Swati VE. She's presenting alcohol attributable liver diseases in India 2000 to 2021 comparative analysis across alcohol policy regimes using GBD 2021.
Is the screen visible?
Yes, ma'am. It's loading.
It's loading.
Yeah, it's now it's visible. You can continue.
Yeah, okay. Yeah. Very good afternoon to everybody present here. My name is Swati and I'm from Christ Team to be University. So today my presentation will be on alcohol attributable liver diseases in India from the years 2000 to 2021. It's a analysis across policy regimes in India. So to give a little background on what this paper is exactly about. So, alcohol is one of the top 10 global risk factors for daily disability adjusted life years. So, the consumption of alcohol, like extreme consumptions of alcohol, can result in either liver cirrhosis and liver cancer. And annually, over 2 million people die due to alcohol related liver diseases. While in high income countries, it's stabilizing or, in fact, even declining in terms of mortality. In low and middle income countries, it's been rapidly increasing over the years. Okay, so the Indian context to this is that in the last 2 decades, alcohol consumption has been drastically increasing, and along with that, so are the disease burden related to it. So this not only has a health impact on the country, but also on economic productivity and working age population. So keeping this in mind, I would like to talk about the data and the case definition. So the data source was Global Burden of Diseases, GBD, taken from the years 2000 to 2021. It's a secondary data analysis. And here, the main focus is on alcohol attributable cirrhosis and alcohol attributable liver cancer. And the key parameters that were taken were years lived with disability, that is the morbidity caused because of the disease, and the years of life lost, that's the mortality, and the total burden, combining these two. And so for this, although I could not extensively choose all the states in India, the states were chosen on the basis of the dominant policy regimes. So liberal states included states that had easy access to alcohol consumption without any stringent laws. So this included Goa, Sikkim, and Punjab. And regulated states or state monopolies are states that have some kind of taxes and laws that regulate the flow of alcohol within the state. So these included Kerala, Karnataka, and Tamil Nadu. And at the other end of the spectrum are states that completely prohibit the consumption or the flow of alcohol. These included Gujarat, Nagaland, and Bihar. So now going on to the results section. So out of the three policy cohorts that I mentioned, liberal states naturally had the highest disability adjusted life years, with Sikkim being at the top of the chain, followed by Goa and Punjab. So I'm saying this with respect to the annual percentage change that was calculated using the logistic model, logistic regression model. And moving on to prohibited states, Nagaland had the highest. Although prohibited would naturally mean that there should be less disease burden, but contrarily here, Nagaland had like the highest disease burden within the cohort, with Bihar in fact having a downward decline even before like 2016, which was when it exactly the alcohol prohibition law was implemented. And then in regulated states, like when we compare it to the other two policy cohorts, they perform rather moderately. They're not at the two extreme ends of the spectrum. They do not have extremely high disease burden, nor do they have extremely low disease burden. They are literally in between. So this can also be referenced by looking at the graphs. As you can see, liberal states, when you compare to the all the other policy regimes, have the highest disease burden due to the free flow of alcohol consumption there, and regulated states have a relatively lower disease burden as compared to prohibited states. So moving on to like cohort level contrasts. So now the next question arises that if basically grouping states into policy cohorts, is it actually, does it make sense? Does it contribute significantly to some kind of analysis? So to answer this question, I used panel regression to get a rough idea of how much of the variation in DALYs or the disability adjusted life years or the disease burden between prohibited and regulated states vary with respect to the liberal state, keeping as the reference category. So the R square obtained was extremely low, and this indicated that grouping states into policy cohorts might not be the best way to explain disease burden across states. So because policy cohort failed, so the next step was to see how the state level contrast performed. Again, keeping in this case Bihar from the prohibited state as a reference, because that had the lowest disease burden of compared to all the other states. So as you can see here, compared to Bihar, Sikkim had the highest disease burden, which also conveniently belongs to the liberal state. So this indicates that still more or less liberal states have the highest number of disease burden as compared to prohibited and regulated states. And it's a significant conclusion that we can come to. So now that we're done with whether policy can actually help us understand the kind of disease burden that's happening in the state, the next question would be, now we're talking about mortality and morbidity burden, right? So are they significantly differing, or are they more or less the same thing? Because there's one thing looking at the numbers, but there's also another thing to get a statistical or a very significant estimate to say that yes, they are differing, and no, they're not. So in order to do that, two tests were undertaken. One was Wilcoxon to see if there's a significant difference between morbidity and mortality, which are YLDs and YLLs. And there indeed is a significant difference. In fact, mortality is a higher contributor to the overall disease burden in every state as compared to morbidity. Further, when you look at it, it's also significantly growing across the years. As referenced by the diagram here, it's clearly depicted that mortality has been increasing over the years while morbidity has been decreasing. In some states like Bihar and Tamil Nadu, there has been a reduction. In fact, it's declining. It shows a little declining trend, but again, it's slowly like starts rising up again. So overall, mortality dominates the disease burden as compared to morbidity, which was also confirmed by the Kendall's test. So moving on to the sex and age differences. So naturally, in a country when there's a excess disease burden, not only does it affect the healthcare infrastructure, but it also affects the economy because the people living there contribute to the economy, right? So here, as much as so, if the younger population gets the disease burden, that means the economic productivity goes down, and also it could lead to overall drop in everything else. So in order to test the significance of that, um, another logistic regression model was run where it is shown that especially men bear the highest disease burden with respect to alcohol related liver diseases. And while in adolescents there's not while
Sorry
adolescents
to
can.
interrupt you, ma'am,
Yeah.
but your 9 minutes are over, so kindly wrap up.
Yeah, sure, sure. Okay, so the overall conclusion is that male in India, especially men, have an excessive alcohol-related disease burden as compared to women, especially at the age group of 30 to 34, 30 to 44, they have like a 78% higher burden as compared to women. So this is skewing economic productivity as well. So the resultant discussion would be, first thing is grouping states based on policies might not very well explain how the disease burden in that state is going on about. And plus, in India, although we have like a diverse alcohol policy regimes, which includes prohibition, regulation, and liberalization, the problem is it's not effectively implemented. And although like regulating alcohol policy seems like the best way out, but because of illicit markets and excessive tax, there's always like a back door through which alcohol consumption happens illegally. So as a result, in we need to take into consideration certain factors while framing policies and make it not too stringent nor too liberal, and keep it in between and make sure that it's also like properly implemented. And so the limitations of the study is that more factors, more economic factors could have been like included into the model, but it was very difficult to patch it all up. So that could also be like a future direction here on out. And so the conclusion is that we need to regulate policies and make sure everybody's equally protected, and the healthcare is also further strengthened. And these are the references. Thank you. I'm open to questions.
Nice analysis based on the very much needed topic of we can say in today's generation. Uh,
Thank you, sir.
so as of such, technically there are no question. Only thing is, so the comparative analysis what you have gathered, is it better based on only the GBD data or is there any other sources of data through which you have done the analysis?
Okay, so sir, GBD is like a platform where they take data from like the central government as well, and wherever there's like missing values, they kind of estimate it and they fill it up. So they GBD is like a repository that takes data from like multiple sources. So that alone.
So that is the authentication through which you have analyzed
Yes, sir.
how you have presented your analysis.
Yes, sir.
Okay, okay. Thank you, thank you.
Thank you, sir.
Okay, moving further. Next, we have SS Barfe. She's presenting Evolving Standards of NLP Evaluation, a
Sir,
survey of metrics for text generation and understanding. Do we
Just
have
1 minute.
sir,
hello?
sir, I am Dr. S. Saulamid.
Okay, okay, you're there, right?
Yes, sir.
Okay, you can
Can I
start.
present?
Yeah.
Okay, sir. Sir, good afternoon to everyone. Today I am going to present our work titled Enhanced Route Discovery and Reduced Energy Consumption Scheme in VANAT using efficient light gradient boosting algorithm. This work focuses on improving routing efficiency and reducing the energy consumption in vehicular ad hoc networks. In abstract, VANAT plays a key role in intelligent transportation systems but high vehicular mobility causes frequent routing failures and data losses. To address these issues, we propose an efficient gradient boosting algorithm for cluster head selection and routing. Simulation results show the improved throughput and reduced delay compared to existing methods. In our work, the VANET is a bus network where vehicles communicate with each other and roadside units. Due to high speed and dynamic topology, maintaining reliable communication is a challenging. So we use an efficient routing is very important for safety applications such as accident alerts and traffic updates. So our problem statement is to existing VANET routing protocols suffer from several issues. Frequent link breakage occurs, especially at crossroads, and energy consumption is high, and cluster head selection is not stable. So this leads to poor packet delivery and increased delay. So to address these issues, the objective of this work is to design a cluster-based routing protocol to reduce the energy consumption and data loss, to improve packet delivery ratio, and to select the stable cluster heads using ELGBA, nothing but efficient light grading boosting algorithm. And the related works with this paper is nothing but several routing protocols such as AODV, PSO based, and ACO based methods have been proposed. Through clustering improves scalability, existing approaches still face high delay and overhead. So this motivates the use of machine learning for intelligent routing decisions. So routing is an important part that works in this paper. And the proposed system overview is our proposed system uses a cluster-based VANET architecture. Roadside units assist in cluster formation, and hierarchical clustering is applied at intersections. So ELGBA is used to select the most suitable cluster heads so that every cluster can easily communicate with each other. And the cluster formation. So vehicles are grouped into cluster based on their location and time interval. Roadside units identify the vehicle positions using GPS information. Clusters are formed according to the lane and the direction, which reduces the routing overhead. So cluster head selection is another important problem. So cluster head selection is very important for network stability. So in our method, cluster heads are selected based on the vehicle speed, node density, and stability. Vehicles with lower speed are preferred to increase the cluster lifetime. So an efficient light gradient boosting algorithm is proposed here so that it improves the version of gradient boosting. ELGBA is an improved version of gradient boosting, and it focuses on important data samples using gradient-based sampling. This reduces the computational complexity and improves the decision accuracy for cluster head selection. Next, the data dissemination strategy. So which comes in an important part. Roadside units divide the large data into smaller segments. These segments are distributed among cluster members. So this strategy significantly reduces the data loss at intersections and improves the reliability. Next, the simulation setup. So the proposed system is simulated using the MATLAB software. The number of vehicles ranges from 150 to 300. Maximum speed is up to 100 km per hour with a radio range of 1000 meters. Simulation time is 100 seconds. And performance metrics, which we evaluated the performance using 4 metrics such as throughput, end-to-end delay, packet delivery ratio, energy consumption. So these metrics helps routing efficiency and the network stability. And the results at the end of the day is the results show the ELGBA achieves the lowest end-to-end delay, and it provides higher throughput compared to MOSIC, ACR, CBL, and EGBCA. So these are the existing algorithms that used for this VANET procedure. The performance remains stable under high vehicle mobility. And finally, the conclusion is to conclude, the proposed ELGBA-based routing improves VANET performance significantly and reduces the delay and energy consumption while increasing the throughput and reliability. So in our future work, this approach can be extended to real-time development, security-aware routing, and 5G VANET integrations. And it also implemented in IoT. Thank you, sir.
So can you go back to your result section, result slide? Okay.
Sir.
So, how you have considered or calculated the delay with respect to end-to-end delay as you have compared?
Sir,
So,
we
comparative
use some.
analysis. So, with
Okay, sir.
respect to existing work, how you have
So,
done with
so that,
respect to matrix?
sir, based on some performance metrics we taken such as throughput, end-to-end delay,
Mm-hmm.
packet delivery ratio, energy consumption. So energy consumption is the main metric that need to be addressed.
Okay. And why only light gradient boosting algorithm?
So we name it as light gradient boosting algorithm, sir. When compared to some other algorithms such as MOSIC, ACR, CBL, and EGBCA. So these are the previous algorithms used for this work.
Mm-hmm. Okay. Yeah, fine. Yeah, thank
Okay, sir.
you.
Thank you. Thank you.
Next, we have Nixon Hali. Do we have Nixon Hali?
Yes.
Yes, sir. So you're presenting industry readiness and regulatory challenges for AI advisory in India financial services.
Right. Yeah.
Okay, sir. You can share your screen.
Yeah. Is it visible?
Yes, sir.
Yeah. Good afternoon, everyone. My name is Nixon. So I'm from KLA Technological University, Hubballi. So this paper is on industry readiness and regulatory challenges for AI advisory in Indian financial services. So basically, these are the keywords. That is artificial intelligence, AI advisory, industry readiness, and financial services. So why AI advisory? Because as it is an era of AI, I am a student in the finance specialization. So I thought of this and studied about this. So basically, 30% AI reduces 30% operational costs. That is, AI has an advantage in terms of that is better efficiency and time and better results. And also there is 80% increase in customer satisfaction, 50% increase in agent productivity, 30% less time on data crunching. These are all based on the previous research which has been done. So next, this is the review. This is the literature. So basically, we are having two objectives. So regarding the regulatory challenge, it was done on the secondary research was done on that. So basically, there are the six things in which there is a challenge for AI advisory. That is fairness and bias, and governance and oversight, accountability and liability, and investor protection and disclosure, data privacy, cybersecurity, testing and monitoring. So these were the major things. These are three reviews which I have put here, but still there are many which had been added into the paper. And so these are the six main things which are challenging for AI advisory in financial services in India. And another thing for another to check the readiness. So responses was survey, a structured questionnaire survey was conducted from 59 respondents. They included independent wealth management firms and financial advisors and fintech firms also. The study was made using JASP software and t-test and multiple regression and other tests was done on this data. So this is the reliability test. That is the questionnaire that which we had given. It got a value of 0.789, so which is pretty good. And correlation was done on willingness to adopt AI and trust. So it has the willingness versus trust. It has a higher correlation. That is, more trust in the AI, it leads to willingness to adopt to AI. And another thing is the readiness and willingness, this factor add a less correlation. That is, it shows that many people are willing to adopt to AI, But since because of the resource constraints, so it is becoming difficult for them to adopt to that. And another thing is the sample adequacy. So this shows that the sample, which I already mentioned, that 59 responses, so 0.78 it has come. So this is which is adequate, with the sample size adequate to do the statistical tests. And this was the factor analysis, that is in this factor 1 and factor 2. So this is the advantage and the disadvantage. So the major contributors to adopt to AI, that is trust in AI. The factors are trust in AI, time saving, and willingness to adopt, cost concern, and AI replacement. AI replacement is that replacing humans. So AI replacing humans in terms of financial advisory service. So trust, time saving. So these were the major promoters which could these were the major promoters to adopt to AI advisory. And cost and replacement were like a negative influencers, like it is the another factor which could hinder, or which could be the potential barrier to adopt AI advisory services. And another thing is the T test, which was done. So in this wealth management and independent advisory, so wealth management has a better possibility to adopt to AI advisory services because of better resources and more better resources and more scope to do so. And independent advisories lack that. This is what we found. And another thing is a multiple linear regression. In this, the perceived utility intent was the one factor, cost and replacement was another factor, AI usage and regulatory awareness were the factors. So in this, it can be observed that AI readiness was greatly influenced by perceived utility and intent factor. That is the productivity which AI advisory gives, and the willingness to adopt to that were the major influencers for AI readiness in the responses. And the limitations is that this study is conducted in the region of North Karnataka, and it is limited to financial services sector, and time was another constraint, and it has 59 responses. And future research could be done on a wider geographical area in coming days. So this is the conclusion. Thank you.
Uh, exactly, what are your objectives of this? There is a work, or what are your objectives of presenting with respect to having a AI advisory in a financial services?
Yes, sir. Sir, actually, the objective was
Hmm.
what are the regulatory concerns, that is which I
Hmm.
mentioned, that is fairness and
Hmm.
bias,
Yeah.
which is on which the secondary research was done for that
Hmm.
objective, to check the regulatory challenges which are there. For
Hmm.
to that secondary research was done. Based on the
Hmm.
secondary research, it was found out that fairness and bias, like 6 points which I want to mention.
Hmm.
Fairness and bias is one, governance and oversight is another,
Hmm.
accountability and liability, investor protection, data privacy, and testing of the AI models which will be
Hmm. Hmm.
implemented. So these were the major six things which were found. These were the major challenges. Pardon me. These were the major challenges which were found in the secondary. I mean the secondary research.
Hmm.
Uh, yes, and for another thing to assess the readiness.
Hmm.
So a structured questionnaire which I already mentioned was done, sir.
Hmm. Okay.
Yeah,
Yeah, fine. Thank you.
thank you, sir.
Thank you, sir. Next, we have, sorry for that. Next, we have Chandramouli ji. He's presenting modeling the barriers to Indian Gen Z's adoption of neo banking services and ISM MIC MAC approach. Do we have Chandramouli?
Yeah, hi Siddesh.
Yeah, hi Chandramouli. You can present your screen.
I'm Chandramouli Ji. presenting our paper titled Modeling the Barriers to Indian Gen Z's Adoption of Neobanking Services, an ISM Micmac approach. This work is co-authored with Suparna Ray and Ashwit from Amrita School of Business. Our study examines why neobanking adoption among Indian Gen Z remains uneven despite strong digital readiness. So neobanks provide digital-only, low-cost, technology-driven financial services. However, in India, Gen Z shows high digital fluency but inconsistent neobanking adoption. In order to address this, we identify adoption barriers and model their structural interrelationships using an integrated ISM Micmac approach based on primary survey data. We identify several interrelated barriers where foundational barriers structurally drive surface level deterrence. This is the literature review. Existing literature on fintech and neobanking largely focuses on adoption enablers, often using UT-AUT based models. Most recent work using innovation resistance theory highlights trust, risk, and institutional barriers. However, most studies treat barriers independently. They do not model hierarchical or systematic interactions, nor do they offer limited structural insight for emerging markets like India. So this motivated our research approach. The key gaps were overemphasis on adoption enablers, barriers treated as independent, not systematic, fragmented evidence on Indian Gen Z, and we had limited structural modeling of regulation, trust, and inclusion. So there was also a very sparse, limited use of ISM Micmac in this context. So accordingly, we asked the following research questions. What barriers inhibit Indian Gen Z's neobanking adoption? How do these barriers interact hierarchically? What insights emerge for regulators and neobanks? Moving on to the research design and methodology we followed, we used a quantitative research design with a structured questionnaire. The target group was for Indian Gen Zs aged between 18 to 27 years of old. And our sampling was purposive. Analytically, we applied ISM, interpretive structural modeling, progressing through SSIM, IRM, FRM, followed by a Micmac analysis to classify the barriers by driving and dependence power. This method is well suited for modeling complex nonlinear barrier interactions. Next, we'll see the sample profile. So we analyzed 100 valid responses with first their balanced gender representation, followed by strong student representation across disciplines, and finally a diverse geographic spread. More importantly, we wanted to validate the response with digital comfort levels were high, followed by privacy and trust concerns were also high. And finally, neobanking awareness was evenly split. This paradox justified a structural modeling approach in our case. So then we identify the adoption barriers. These are the 11 barriers, as you see. The regulatory ambiguity, digital literacy barriers, technology reliability doubts, awareness gaps, security and fraud concerns, financial data misuse anxiety, hidden cost concerns, trust deficit, perceived irrelevance, lack of personal interaction, eco-ethical concerns. So these barriers span institutional, technological, economic, and psychological dimensions, which reflect a multi-layered nature of neobanking resistance in an emerging economic context like India. So these are the ISM results. The ISM hierarchy shows that regulatory ambiguity, digital literacy barriers, and technology reliability doubt acts as foundational drivers. These influence the awareness gap, which links to downstream concerns. And then the trust deficit and perceived irrelevance emerge as dependent outcomes. Eco-ethical concerns show minimal systematic influence. So overall, this indicates the surface level adoption issues cannot be resolved without addressing the upstream drivers. Moving on to the Micmac classification, we further analyzed, classified the Micmac classifies these barriers into four types, namely the driver barriers, linkage barriers, dependent barriers, and autonomous barriers. In driver barriers, we have regulation, literacy, and reliability. In linkage barriers, we identified awareness, security, cost, and data misuse. In the dependent barriers, we were able to find out trust deficit, irrelevance, lack of interaction, followed by autonomous barriers having the eco-ethical concerns. So this helps to prioritize where intervention should begin. Overall, the adoption barriers among Indian Gen Z are structurally interdependent. Regulatory literacy and trust factors act as foundational drivers. And theoretically, the study integrates UT, AUT2 and innovative resistance theory through an ISM MICMAC framework, extending fintech adoption research to an emerging market context. And the practical insights are that without regulatory clarity and digital literacy, surface level fixes are unlikely to significantly improve the adoption. And these are the references that we'd used. Thank you for your attention. I look forward to your questions.
Sir, understanding the model what you have delivered here. So, new banking services, what exactly you're trying to ensure about the financial terminologies in Gen Z adoptions?
We are trying to model what are the barriers that these neobanks face in terms of adoption by the Indian Gen Zs.
Okay, so what are the major areas what you are focused for Gen Zs considering banking services?
So it could be the what are the drivers of that cause their it could be in terms of the regulation, banking industry mainly covered by the Reserve Bank of India in India. And in terms of literacy rates, what is the reliability of these neobanks, whether their trust factor, how secure their money is in terms of security, cost, and data misuse, and in terms of how relevant these neobanks are, and there is a lack of interaction with these neobanks. There's a lack of personal touch. So that is one sort of driver, the dependent barrier that we are trying to model. So to summarize, the barriers we are classified as driver barriers, linkage barriers, dependent barriers, and autonomous barriers.
Yeah, thank you. Thank you, sir.
Sure, thanks, Sanjay.
Thank you, sir. Next, we have Parinitha P. Rao. She is presenting Vision-Based Perception for Robotics Bin Picking, comprehensive survey of 6D pose estimation and grasp detection techniques.
So, is the presentation in slideshow mode?
Yeah, ma'am. You can continue.
Okay. Yeah. Thank you. Good afternoon, all. I am Parinita P. Rao, and today I will be presenting our survey paper titled Vision-Based Perception for Robotic Bin Picking, a comprehensive survey of 6D pose estimation and grasp detection techniques. This work has been carried out in collaboration with Vinita Kopalkar and Manjesh R. from Vidyavardhaka College of Engineering. Our study focuses on how modern vision-based techniques enable robots to accurately perceive, localize, and grasp objects from cluttered industrial bins, an essential requirement for next generation automation. So, here's the brief overview of today's presentation. I will begin with abstract, followed by the introduction, where I'll explain the motivation behind the robotic bin picking. Next, I would discuss the problem statement and provide a structured literature review. I will then introduce the key data sets that can be used that we have found out from the literature survey. Then I would explain the proposed methodology derived from the recent research, and then I would highlight the challenges and issues in vision-based picking. Robotic bin picking requires reliable perception to estimate object pose and determine stable grasps in cluttered environments. However, existing approaches struggle with occlusion, object symmetry, reflective surfaces, and high annotation costs, and often fail to generalize to unseen objects. In this survey, we systematically analyze 60 pose estimation, grasp detection, data efficient learning, and generalization strategies. We highlight how techniques such as multi-view fusion, dense grasp prediction, self-supervised learning, and few-shot methods significantly improve robustness and adaptability in real-world industrial applications. Robotic bin picking is a fundamental task in modern manufacturing and logistics, where robots must pick objects that are randomly stacked and partially occluded. Accurate 60 pose estimation and grasp detection are critical yet extremely challenging due to clutter, symmetry, textureless objects, and sensor noise. Many traditional approaches rely on single view perception, object specific training, or large label datasets, which limits scalability and flexibility. Hence, this motivates for a need for robust, data efficient, and capable of generalizing to novel objects. Despite significant progress, existing bin picking system fails and there are major limitations. They struggle in heavily occluded scenes, depend on large object specific annotated datasets, and show poor generalization to unseen objects. Therefore, the core problem addressed in this work is to design an approach that enables robust 6D pose estimation and stable grasp detection in cluttered bin picking environments under limited labeled data and unseen object constraints. This problem forms the foundation for the survey and proposed framework discussed later. So, this is the literature review that we have done. So this table provides a comparative summary of the key research directions. For 60 pose estimation, correspondence-based methods such as E-pose, zebra pose, and high pose offer high accuracy but are computationally expensive. Direct and hybrid methods like GDR, net, and SO pose improve efficiency but remain sensitive to occlusion. Then multi-view and temporal fusion techniques such as quasi pose and video pose reduce occlusion effects but increase system complexity. For grasp detection, methods like AnyGrasp, RSPFG-net generate dense and stable grasp candidates but rely heavily on accurate perception. So this slide is of the open source data sets that are available and that we have found from the literature survey that we have done. Coming to the objectives. So first, it is to develop a vision-based framework for robust robot bin picking. Then secondly, it is to improve robustness and adaptability compared to single view and object-specific methods. Third is to reduce the dependency on manual annotation using synthetic, self-supervised, and few-shot learning strategies. Finally, it is to also analyze the performance using post accuracy, grasp success rate, robustness under occlusion, and generalization capability. So this is the proposed methodology. In the proposed methodology, this is a multi-stage, we will be building a multi-stage vision-based pipeline, and it begins with multi-view RGBD acquisition to handle occlusion. Next, Instance level segmentation and 3D fusion produce clean object representations. Then 60 pose estimation is performed using correspondence based or few shot learning approaches. This is followed by dense grasp prediction, generating multiple stable grasp candidates. Finally, supervised refinement allows the system to learn continuously from robot interaction and feedback. So the challenges and issues are, so perception is affected by several occlusion, clutter, and difficult object properties such as symmetry, reflectivity, and transparency. From a learning perspective, manual annotation is expensive, and generalization to novel objects is still limited, especially in cluttered environments. System level challenges include error propagation across pipeline stages and real time collision free motion planning. To conclude, vision based robotic bin picking has evolved from classic geometric methods to deep learning driven approaches. Advances in 60 pose estimation, dense grasp detection, and data efficiency learning have significantly improved performance in cluttered environments. However, challenges in generalization, data dependency, and system integration remain. So, future systems must move towards foundation models, self supervised physical learning, and end to end robotic pipelines to achieve true autonomy. These are the references, and thank you. I'm open to queries.
So, ma'am, based on the we can say the survey or a review which you have carried out with respect to 6D pose estimation and graphs detection. So, what is your thought process?
I didn't get your question. Like, can you
So,
elaborate?
you have done the survey on 6D pose estimation and
Yes.
a graphs detection technique.
Yes.
You did a survey on these methodologies for a vision-based perception for robotic bin picking. So, can you
Yes.
give the analysis of what are the means future plans that, as you are say, you have analyzed the existing work which has been carried out, and you showed the objectives what you are going to do it. So, what is your thought process? How exactly improvisation need to be considered with respect to availability of it may be with respect to 6D pose estimation, or it may be with respect to graphs detection technique. So, how it can be improvised?
You mean my understanding of the literature
Yeah,
review
yeah, yeah,
that
yeah.
has been done? Okay, so basically here there are three
Hmm,
components uh, that we are addressing. One is perception, then
hmm,
the next is grasping, and then the third one is control.
hmm,
So for the perception, we have okay, like right now, because in the occluded environment, the existing systems fail to capture uh, and understand the pose at which the object is. So it is not able to correctly perceive, and that is why it is not able to grasp it properly. Secondly, these systems fail when the objects are symmetric and when the surfaces are smooth because it's not able to pick it up properly. Thirdly, the existing systems right now are able to grasp only a single object. They at a time are not able to pick multiple objects. So this is the summary of the literature that we have done.
okay.
And in future, the the robotic automation that we would be working on would be to pick multiple objects at a time. It would be
Hmm,
able to pick symmetric objects and
hmm,
place it properly. And thirdly, it should be robust and generalized. It
Okay.
ca- it if we keep training it on label data sets, then it would again be repetition of the existing systems.
Okay, ma'am. Yeah. Thank you.
Thanks.
Thank you, ma'am. Uh, Perfeman, can you try to speak now?
Good evening, everyone. Myself, Sapna Barfe. I am presenting Evolving Standards of NLP Evaluation, a survey of metrics for text generation and understanding. As we know, NLP is a subfield of AI where human can interact with the computers. There are various applications of NLP like text classification, summarization, machine translation. In order to check the performance and effectiveness of the model, we need to have some quantitative measures, and this is described in this paper. So the first approach is a n-gram matching approach. Basically, there are four types of evaluation metrics. First one is the n-gram matching approach. This metric is commonly used metric. It works at character level as well as word level, and this metric is used to assess the text similarity between the system output and the reference text. And Rouge, Belu, Meteor, and CHRF. These are the examples of n-gram matching approach. The next is the edit distance based metrics. Here, the humans can make some edit operations like insertion, deletion, substitutions, shifts in order to match the reference translation. And TER is the one example of edit distance based metrics. Next type of a metric is the embedding based metrics. Here the embeddings are used. That means the text is converted into the vectors to capture the semantic and contextual information. Basically, there are two types of embeddings. First one is a context independent embedding where the same vector is assigned to the word regardless of the context. And the second one is a context dependent embedding where the each word has a different vector depending on its surrounding words. For example, bank, if we consider a word bank, it can have two meanings: the bank of the river, and the second one is a financial institution. So it is important to consider the context in which that word appears. So word score is the embedding based metric. This is a learned matrix. It is used to assess the quality of machine generated text, and it uses the human annotated data where the pre-trained models are trained, and it gives the output based on their contextual semantic meaning. For example, Bluert and Comet. Here, the metrics are explained. Metrics are described briefly. The first is a precision. Here, it denotes how many of the predicted positive instances are actually correct. The second metric is a recall, which means how many of the actual positive instances are correctly identified. These two metrics are used in the confusion matrix, and using this precision and recall, the third metric is used, that is F1 score. F1 score balances the precision and recall, and it takes the 0 to 1 values. Next metric is a rouge. This metric is used in a summarization evaluation. There are variants of rouge. First one is a rouge one. It works on the unigram level overlap. That means it considers only a single word. Bigram level overlap is a rouge 2. The rouge L is the longest common subsequence. Rouge S is a skip gram, and S is a skip bigram plus digram. These are variants of rouge which are commonly used in the summarization. Rouge metrics achieve the correlations above 0.75, sorry, with human judgments on the DUC 2001 datasets for long summaries. Next, it has some limitations like it measures only the n-gram overlap and it ignores the semantic meaning. It does not consider the meaning of the text. And the second limitation is that it correlates more with the human judgments for the extractive summaries. That means the summary, the sentences are taken as it is from the original text, it works correlates moderately with those summaries, but it works poorly for the abstractive ones, where the few sentences are generated from the text. Next metric is a bilingual evaluation under study metric, which is also known as a Belu metric. It used to determine the level of similarity between the system and reference text, and it takes the values from 0 to 1, where the 1 represents a perfect match and 0 represents there is no match. Here in Belu, two stages are done. First one is a tokenization, in which the text is converted into the individual tokens, and then the engrams between candidate translation and reference translations are matched. There are various applications of bilingual evaluations under study, like machine translation, text generation, text summarization. Belu is a reliable, that is the main advantage of a Belu, and there are some disadvantages of Belu is that it has a brevity penalty only to short translations. That means if the reference translation is bigger than the machine generated translation, then it uses the brevity penalty to adjust the score, and it totally depends on the n-grams. That is the second disadvantage. It measures the string similarity, does not focus on the semantic correctness, and it works well with the large data set with the multiple references. The Belu, sorry, English to French and Chinese to English translations, the Pearson correlation coefficients are given in the sorry, but I can't see it properly. Second is a the next metric is a cross-lingual optimized metric for evaluation of translation, which is it supports more than 100 languages. There, it works in using two models. First one is estimate model, where the three sentences like source sentence, machine generated hypothesis, and human reference sentence is given to the system, and then it generates the vectors. These vectors are concatenated into one long feature vector. Feature is again given to the feed forward regression that calculates the quality score for the translation, and at the end the model tries to predict the scores for this translation, and it checks how far it is from the human generated score. Next is a translation rank model, where the each segment is converted into the vector using cross-lingual model, and then into the link there we generates the fixed length sentence embeddings, and then it is optimized using the triplet margin loss to achieve semantic closeness between the matching hypothesis and the anchor. That means the triplet margin loss takes three inputs. First one is a positive hypothesis, second one is a negative hypothesis, and then it checks the relation between the positive hypothesis and the source. It has some advantages, like it can be easily adjusted to match the different human evaluations, and it works well at the single sentence level. Next point is the disadvantages of this technique. Pre-trained models have too many parameters, and it takes too much time. The disadvantage of this, and here the source and reference are given the different importance before the training, and after the training they are treated the same. That is the main disadvantage of this metric. Here the Kendall's coefficient tau with the English as the source language is given, that is 0.603 and 0.033 with English as the target language for WMT 19 metrics on the dark corpus. Next is a translation error rate. It measures how many edits that a human can perform to fix a machine. To fix a machine translation to match the reference exactly. The advantage is that it correlates well with the human assessments, and disadvantage of TR is that it makes more translation errors. Next is the character engram F score, which is also known as a CHF. It compares the system output with the human reference translation using character level engrams, and there are three. It works at the two levels, that is a segment level and a system layer level. Here, the system level correlation is nothing but the comparison of entire translation system. It does not consider the individual translation system. It takes all the translation systems and then check whether the ranking of the system performed by the CHRF matches the human ranking. It focuses on the order, not the exact score order.
Sapna ma'am,
Next, hello.
sorry to
Yes,
interrupt,
sir.
but your 9 minutes are over. So kindly wrap up.
Okay, sir. And next is a Pearson's R linear correlation. Next level correlation is a segment level. It works at the sentence level. Kendall's correlation is used to measure the relationship between the CHRF and humans. And these are the advantages, disadvantages of CHRF. Next is a meteor, which is known as a metric for evaluation of translation with explicit ordering, in which three modules are used. First one is the exact module, where the unigrams from the reference text and the machine generated output are considered and they are mapped. Next one is a Portal stem module. It generates the additional mappings for the stem unigrams to capture the morphological variants. WN synonymy. If the two unigrams are synonymous of each other, then they are mapped. Next one is a bird score. In this bird score, the contextual embeddings are performed. That is, here the same word has the different vector depending on the context, and then the cosine similarity is used to check the similarity between the candidate token and the reference token. The advantage of BERT score is that it is used to check the paraphrase detection task, and it works with the human alignment at the segment as well as system levels, and it indicates a strong correlation with the human evaluations in the context of image captioning. There is a bilingual evaluation under study.
Ma'am,
Yes, sir.
your time is up, ma'am.
Thank you, sir.
Yeah, ma'am.
Sorry, sir.
No worries, ma'am. Uh, Dr. Sanjeev Kumar, do you have any questions?
Hello.
Yes, sir. Do you have any questions? Sanjeev Kumar, sir, do you have any questions?
Hello.
No, ma'am, not you. I'm asking to the chair if they have any questions. I take it as no. Okay. Thank you, ma'am. You can stop your screen sharing.
Thank you, sir.
Yeah. So this was our last presentation for this session. Moving further, so I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for for your support during the 10th version and all previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team ICTCS 2025. I also thank our session chair for this session, Dr. Sanjeev Kumar Angadi, for chairing the session. A small token of appreciation on behalf of Team ICTCS 2025 and Global Knowledge Teachers Foundation and partners. Sir, do you have any closing remarks for the participants?
Hello.
Yes, sir.
Yeah. Uh, presentations and the considered by the author, and as per the trending, every the best for their maybe their final year project work. So all the best, and I'm thankful to the conference chair for giving me the opportunity to be a session chair for all the authors, those who are present. Their work. So thank you, sir. Thank you.
Thank you, sir. Thank you so much. Thank you for your valuable presence. I request everyone to switch on their cameras for a quick snapshot. Thank you, everyone. Have a good day.